All right, so some examples of the products and the subject areas that are covered by the scheme for, we'll just call it for North America. It's essentially most all plumbing components on the delivery or discharge side of a plumbing system. And as you can see, the product categories, it's the primarily fixtures and fittings, gets into drinking water treatment units, pipes and fittings, drain, waste and vent, backflow prevention, and even septic and septic tank components. The primary areas covered are material toxicity, backflow prevention. There's a water efficiency criteria that's covered within the components of both the fixtures and the fixture fittings. Scald and thermal shock protection. Alternate water source is also covered, as well as accessibility and use by the disabled. So where does it all start? So standards. So here's back to a little bit of the elementary part that I know a lot of folks here know. What is a standard? It's primarily the set of technical definitions and requirements. So primarily it's the performance aspects of all the products. The criteria covers a lot of what we had just talked about. Beyond some of the toxicity and backflow things, it also covers temperature and pressure, as well as corrosion resistance, life cycle, things of that nature on a lot of the products. And it also, in some cases, gets into marking requirements. Well, the other primary thing to mention is that the standards themselves hold no regulatory authority. That's a critical component. So how are the standards developed? There's primarily two standards development organizations that accredit standards writers in the US and Canada, and we'll talk about them in a minute, but primarily standards development organizations get accredited by those organizations, and then they are acting as the secretariat to write those standards. The plumbing standards are usually developed by trade associations, certifiers or test labs, or professional associations in North America. And the list of the logos down below are primarily the ones that handle a lot of the plumbing work. And as I mentioned, they're accredited based on the standards developers for the US and Canada, which is going to be the next slide, which is the American National Standards Institute, represents the US, and the Standards Council of Canada represents the Canadian organizations for accreditations. These two organizations do not develop the standards themselves, but they give you the criteria for the standards development organizations to use to develop those standards. They help to facilitate that standard development activity, and it's usually under the guise of the ISO 17065 accreditation criteria. There's over 200 accredited SDOs in the US and Canada, and all of the standards are developed primarily under the principles of a consensus standards development. So it's primarily focusing on the openness, so all material affected parties can participate in the development activity. It's a transparent process, so there's records and the processes are open and public. And there is a due process scheme to it so that it's written, documented, and there's an appeals process. And it's also under consensus, whereby there's no one individual group or entity can have a majority on any of the committees. So this is an example of some of the consensus aspects that are used with some of the interested parties that typically participate in the North American standards development activities. ANSI's designation indicates that a code or standard reflects the current technology, is responsive to market demand, and contributes to the effective and efficient operation of commerce within a free market environment. And similarly, the Standards Council of Canada's designation indicates that it's been developed by consensus of balanced committees of stakeholders. They're subject to public scrutiny. They're consistent with or incorporate existing international and pertinent foreign standards, and it does not act as a barrier to trade. So the reliance on voluntary and consensus codes and standards development is intended to help the government operate more efficiently and reduce the regulatory compliance and procurement costs, and also avoid duplication between different government entities. So in North America, there's been a lot of harmonized standards development in the plumbing sector with, I guess you would call them mature standards. Many of the standards for fixtures and fittings have been harmonized. ASME, IAPMO, and CSA have worked together to harmonize the most often utilized industry standards, primarily the 18.1 and B45 standards for fixtures and fixture fittings. But ASME, CSA, and ASSE have also worked to develop harmonized standards, primarily in areas covering temperature compensating products. One of the interesting things to talk about, even though most all standards are developed, are accredited standards, some of the organizations, SDOs in the US and Canada, have procedures in place to enable new technologies to get into the codes and into the standards a little bit faster. So they would go through a process of developing standards through an expedited, non-accredited program so that we can try to get that new technology into the marketplace faster, with the premise that generally within a few years you try to incorporate those requirements of the non-accredited portions into the accredited standards. So the next piece of the puzzle, the codes. So the codes primarily provide the legal framework for setting the mandatory product requirements. The codes apply to the installation, alteration, repair, relocation, and replacement and maintenance of plumbing systems within those jurisdictions. It's primarily, as mentioned, it is basically an installation requirement, and once adopted, it is then enforceable. So in the United States, the 10th Amendment to the U.S. Constitution gives the states rights to legislate and protect the public health. So they are the ones that would basically be doing all of the adoption of any of the plumbing codes or standards. States typically adopt a model code with specific state amendments to measure up with some of their climatic issues or things in their regional areas that might be special. And the enforcement also resides with those local jurisdictions. And typically this is where some of the challenges come in, because no two states typically enforce alike. And as Dave mentioned earlier, there's over 44,000 jurisdictions in the United States, and that sometimes creates some complexity. So in the U.S. right now, there's primarily 3 model codes that are used and adopted throughout the United States. The Uniform Plumbing Code, the International Plumbing Code, and the National Standard Plumbing Code. Like many of the standards for doing accreditation, plumbing codes can also be done and developed in an accredited process. The IAPMO Uniform Plumbing Code is done through the ANSI process, where it's a consensus, open, transparent program. It's published on a 3-year code cycle, and one of the other important aspects of the enforcement segment is it includes conformity assessment provisions within the code. The International Plumbing Code is published on a 3-year cycle. It also includes conformity assessment provisions, and one of the differences there is they use a government consensus process, whereby the government entities are the ones that vote on the changes to the code. The National Standard Plumbing Code is also on a 3-year cycle, and it also includes conformity assessment provisions. They use a consensus process for the development of their code, but they don't register it as an ANSI standard. So this is a U.S. code adoption map that shows some of that complexity that we had talked about a little bit. There's a big fragmentation across the country. You can see in some of the areas where they're solid, those are typically a model code has been adopted for that state. If there's cross-hatching or checkering, that typically means that there could be multiple codes adopted within that state, or there might be jurisdictions within those states that have varying adoptions of one of the model codes. There's also a few states that write and adopt their own code as well. So for Canada, the codes are primarily done through a central direction under the Canadian Commission of Building and Fire Codes. It is a consensus-based process. Similar to the United States, the adoption and enforcement of the codes is the responsibility of the provincial and territorial jurisdictions and the authorities, and they're differing from the U.S. model codes. There are no conformity assessment provisions within the Canadian National Plumbing Code. However, they basically rely on references within that standard, or references within the code for the applicable standards. And this sometimes also runs into some problems with acceptance and uniform practices throughout the nation. So here's the Canadian code adoption map, and it also has a reference up on the left-hand part of the screen that shows the National Plumbing Code of Canada, and that one is developed on 5-year cycles with intermittent updates throughout that time period. But similar to the U.S., the solid shading here shows that those are provinces or territories that typically just adopt or adapt the National Plumbing Code of Canada. The bright green and the checkered green, they publish their own codes, but it's primarily based on the National Plumbing Code of Canada. And for Alberta and Quebec, the one reason why I wanted to highlight them is that primarily what I mentioned earlier is a code is an installation requirement. So all the enforcement is done at installation. Alberta and Quebec differ whereby they have regulations that it's required to meet the requirements of the National Plumbing Code in order to sell the product. So that's a primary difference there. So the next piece of the puzzle, conformity assessment. So conformity assessment's the process used to show that a product or a process meets the specific requirements. You can demonstrate compliance to customers and regulators. It gives specifiers, customers, and end users that confidence that that product is going to be safe that when they select it. It also allows manufacturers to distinguish their products from the competitors. And most importantly for industry is it creates a level playing field. And while it doesn't eliminate it, it does help to minimize risks of litigation exposure. So primarily for conformity assessment, there's 3 different levels. You can do first-party certification where a manufacturer can self-declare. On a second-party certification, you can have a product purchaser declare, or you can have an independent test lab do a test report that would represent compliance. But the primary mode of conformity assessment in the U.S. and Canada is third-party certification. And that declaration, that is the declaration from that authoritative independent third party that reviews and all of the manufacturer's informations, does an assessment through testing and other guidelines that we'll talk about. And then the most important part that was previously mentioned is that the third-party conformity assessment is required as a part of each one of the model codes in the U.S. So similar to standards accreditations, certifiers can also be accredited to meet the code requirements. They have to establish the minimum acceptance level of performance. They can identify competent product certifiers, and they ensure the highest level of confidence and compliance, and here again levels the playing field. So the third-party accreditors in North America here again are the American National Standards Institute and the Standards Council of Canada, and they also use the 17065 guidelines under this criteria as well. So the certifier's role in the third-party conformity assessment, the primary objective is to assure that the product continues to meet the applicable performance requirements after its initial certification. And in order to do that with the rules in North America, the certifiers must be accredited, as mentioned. They would then in turn evaluate the products from the manufacturers for all of the applicable performance requirements. And in many cases, there's also a few governmental regulations that get covered as a part of that as well, because it kind of rolls into some of the performance for material toxicity and also for water efficiency. The one key component is that I mentioned there's over 200 SDOs. Each one of those SDOs can set their own policies and procedures, but they still have to follow the guidance of those standards accreditors. So a manufacturer's role in third-party conformity assessment, this isn't talked about often. Usually when you talk about SDOs, you're focusing on the certifier. But the manufacturer also has a role in verifying the conformity assessment. They go into contractual obligations with whichever certifier that they choose to basically verify and swear that they will continue to always maintain continuing conformance of that product. So they open themselves up to audits and unannounced access to their factories and their warehouses. They have to prove traceability. They have to have verification of all their quality programs in place and ensure that those quality programs that they're using to manufacture those parts are being covered within that quality manual. And they also have to verify that if they have any discrepancies, they will go through the process for dealing with them in the corrective action procedures that are identified by their certifier. So when you look at the manufacturer, they'd say, well, what do we have to do to make sure that, that we are in continuing compliance? And that is essentially any change that you make. So if you make a source change for a material from a material supplier, or if you're making any design change, you still have to verify that whatever that change was did not impact the performance of the product. If they wanted to change part numbering schemes, we have to be able to do a review. They don't necessarily have to retest, but they have to be reviewed and ensure that all of the certificates of compliance would match up with all of the information that's been provided. And again, any process changes that they would make that could potentially impact the performance of the product must be evaluated. Here again, it's all with the objective to assure that the product continues to meet those applicable requirements that it was initially evaluated against. So marks of conformity play an important role because they indicate that the product's been independently evaluated against those applicable requirements. They're required to be applied on the product and packaging so that they're, well, primarily on the product, so it is visible and permanent after installation. That's one important caveat that people don't often think about, is the permanency aspect of the markings. And they provide assurance to the purchaser and to the code officials and AHJs that the product is compliant with the applicable requirements, whether it be the code requirement or specific standards. These marks are used under license with the specific agency that the manufacturer uses to be their certifier. So all of these marks shown on the right are representative of some of the plumbing product certifiers in the U.S. And the one mark that I wanted to mention that was talked about a little bit earlier was the EPA WaterSense mark. So EPA WaterSense is a voluntary program. It's not mandatory. However, the guidelines by the US EPA are pretty stringent. If you do want to participate in that voluntary mark, in that voluntary program, you have to use the WaterSense mark, and the identification of the certifier gets placed with the mark, and that has to be on all your product literature and packaging. Here's a couple other examples of some product markings with the third-party certifiers that are being used. This particular product has many certifications that they're using. Here again, they're all molded in, so they're permanent and they're visible after installation. Oftentimes the requirements are, the markings are required by federal law. The Energy Policy Act in the US requires that flow rates be marked on fixtures and fixture fittings, and some appliances. Products and packages have to be marked with the certifier's mark of conformity, and primarily some of the markings that are required are the manufacturer's identification is typically always required on the product, as well as the certifier's mark. So the final piece of the puzzle is the enforcement. The code enforcement, as mentioned, is the responsibility of the local authority having jurisdiction. That is the states and those local townships and cities within the states. Since the codes are an installation requirement, enforcement is typically only done on jobs that are permitted through a city or a jurisdiction. So any products that are do-it-yourself products that were purchased through retail or online typically don't get inspected in the US and Canada, with a couple of exceptions. Alberta and Quebec, as mentioned earlier, where it's illegal to sell the product unless it's third-party certified. But one of the good things is that the retailers, the big box retailers in the US, primarily Home Depot and Lowe's, which combined in the US and Canada probably have well over 5,000 locations, they typically specify to their suppliers of any product, whether it be electrical or plumbing, that they must be third-party certified. There are a few regulatory requirements as far as entering to commerce that I didn't get into too much previously, but the Energy Policy Act in the United States covers the water efficiency requirements of plumbing products and appliances, and also the Safe Drinking Water Act covers the material toxicity of some of the components used in drinking water, primarily lead. And those are enforced through the government, and it is a enter into commerce requirement, so it's illegal to sell. It's illegal to enter into commerce, and oftentimes people say that the definition of enter into commerce is when you manufacture it. It's entered into commerce. So typically those are only enforced when there's complaints. The primary example is a lot of shower heads. We have these water efficiency requirements that are extremely important, and most of these shower heads that are being purchased online, some of them flow up to 11 gallons a minute when the Energy Policy Act max is 2.5 gallons a minute. So typically manufacturers want a level playing field, so they're going to complain to the Department of Energy, and then they'll finally go through and do some enforcement. And so I know that industry through Plumbing Manufacturers International has been involved in some of those efforts previously. Also, some enforcement, while it's not typical and done every day, there are instances where the U.S. Customs and Border Patrol, through their importing of the products. They're looking for products that may be mismarked, and they do some enforcement on trademark infringement if they see if they see products coming in that have a certifier's mark. They often will look on the certificates of compliance on the certifier's websites, and if they don't see that manufacturer's name, they seize the product and then reach out to the certifier. So that happens more often than you think. There's really no primary fines or anything, since all the jurisdictions do their own enforcement. They all have different regulatory requirements, but primarily on the red tag job, which many of you plumbers and past plumbers in the room know, when you get the red tag, you have to take some action. And it generally rolls downhill back to the manufacturer, and they want to make sure that they don't have jobs that get red tagged, because they end up getting their product yanked out, and then that product never gets purchased again by those contractors. So that's the primary incentive. So really, without the adequate enforcement, none of the hard work done by all the standards development organizations and the code agencies or the independent test labs really matters. And in the U.S., industry plays a very big role in the standards development activities, and the plumbing manufacturers in the U.S. and Canada have a very big vested interest and play a pretty vital role in the development of all this work. So here's how it all comes together. So the codes and regulations, they're intended to protect the public health. The standards dictate primarily the performance of the product. The conformity assessment is the scheme for trying to ensure that we continue to meet those requirements, and then the enforcement helps to ensure that health and safety of the end users and the environment. And in the U.S. and Canada, as mentioned, they all play a pretty vital role. It's a pretty effective framework, and most importantly to the manufacturers, is it creates that level playing field. So a couple of the observations relative to our program scheme here in the U.S. I think the aspect of the conformity assessment provisions in the U.S. codes is really key to the enforcement of these products when they're being installed, and to ensure the safety for the end users. The other key strength, I think, of the program is the ability of the SDOs, several of the SDOs for the historical mature standards, to get them harmonized. I think that definitely has been helpful to the industry as a whole, both for the AHJs trying to do the enforcement, as well as for the manufacturer, certainly. But the process is still a little cumbersome. There's still a lot of duplication of effort, and I think that's one of the areas that we could try to work on, getting some better refinement and simplification of things. I think the lack of a singular North American model code sometimes creates conflicts. And if you look at those jurisdictional adoption maps, all of the different jurisdictional practices for adoption and the premise of the multiple codes definitely creates non-uniform acceptance. Part of the challenges with, even if we were to get into, if we had one code, some of the challenges we run into is the jurisdictional timing for adoptions of the new codes. We know there are some jurisdictions out there that are still on the 1998 plumbing codes. So generally, manufacturing sector as well as the certifiers always try to certify to the latest version of the code, because that includes the latest, newest technologies, but sometimes the enforcement isn't following that guideline. So that does create problems sometimes. So with that, I'll take any questions.
It's not really a question. You mentioned that there aren't really any fines associated with the system in the U.S., but just a point for our offshore people, the Energy Policy Act did place in it a mechanism for fines for the laws. So there is some significant fines that you can, but it's all based on federal laws, not really based on the codes and standards.
Right. Thank you for bringing that up, and it is extremely substantial, because if I recall, it's like $5,000 a day per device per day. So if you, like for example, I mentioned that 11 gallon a minute shower head, that could get pretty exponential pretty quickly if the government did decide to do the enforcement. Typically, they go after the product, they let the manufacturers know that they're not compliant. U.S. Customs seizes products upon import, and that's generally how they're trying to do a lot of the enforcement. But that's still a big challenge. There's a lot of ports of entry in the U.S., and not all ports of entry take an equal enforcement action. So that's not the way we want to enforce. We want to be able to enforce, you know, at the local level.